Challenge 30. An isosceles triangle is a triangle that has at least two equal sides. The diagram below shows examples of isosceles triangles. In each diagram, the marked sides are equal. Write an algorithm for a computer program that determines whether a triangle is an isosceles triangle. The user inputs the lengths of the three sides as length 1, length 2 and length 3. If any two sides have the same length, the program outputs isosceles. Otherwise, the program outputs not isosceles. So this is going to help us to understand how we use some boolean logic or logic operators in our code to compare the different sides. So what we're going to do is, it says here the user inputs the lengths of the three sides as length 1, length 2 and length 3. So that's one of the easiest questions I've seen in terms of knowing what to call your variable names. Then it says if they have the same length, then the program outputs isosceles, and otherwise not isosceles. So we know we're going to have an if statement as well. So let's make a start with the easy bit. We are going to have three variables. In fact, I'm going to type one and then copy and paste it. Again, these could be floats because the lengths could be a decimal, but they're definitely inputs, and it's going to have roughly the same message. So we're going to put enter the length of side 1. I'm going to copy and paste this twice. In fact, let me put in my n as well first. So we've got length 1, length 2 and length 3. Change the output message slightly, and that is all of our inputs. So now what we want to do is compare the lengths. So we just need any of them to be equal. So we're going to say if length 1 is equal to length 2, or length 1 equals length 3, or length 1 equals length . So that's every possibility that we could have. Length 2 is equal to length 3, length 1 equals to length 3, and length 1 equals to length 2. So that is all of our possibilities that we can have that are equal to each other. Now if any of those are true, so if length 1 is equal to length 2, or if length 1 equals to length 3, or if length 2 equals to length 3, then we are going to print out the triangle is isosceles. And if it's anything else, then we're going to print out that it's not isosceles. So I'm just going to copy and paste this. And let's have a little test. Put spaces in the variable names. Try again. So enter the length of side 1. I'm going to put 10 and 10 for 2. And then it doesn't really matter what I put for the third one. We know that it's isosceles because they're the same. And let's try putting 3 different numbers in. So we'll put 4, 5 and 6. Not isosceles. So we know that it's working. And that is how we use boolean operators. We've got or and or. And it basically means that you are applying the logic exactly like you do with a logic gate or a logic circuit. You need this condition here to be true, or this one to be true, or this one to be true. You just need any of those to be true. Doesn't matter which, doesn't matter if all of them are true. It just means that one or the other needs to be true, and then the output will be true, which means we'll do this line. So that is challenge 30 complete.